previously, and then my links to socials. Very active on LinkedIn. Yeah, I'm a LinkedIn guy. All right, so today we're talking about this. Don't get scared. It's quite a handful. It's quite a lot. Some of them are quite interesting. In fact, everything is quite interesting. Is really interesting. You really enjoy it. It's quite a lot. So just take the time. For any point you don't understand, just take note of it, and then I'll be ready and willing to take your questions whenever possible. So today we'll be looking at databases. I'll be just a brief overview about databases, and then we'll go into Amazon RDS and Aurora. Look at DynamoDB, Elasticache, DocumentDB, MRO, QuickSight, Glue, Redshift, Athena. All of these things here, we're looking at them so you can fully understand these services, the database and the analytics services that AWS offers quite a lot. All right, so let's look at databases. Databases are we call it a structured system of organized data, which means where you save data, it's not like your flat file. You know, you can save your data, write something in a flat file, and then save it, and then you can retrieve it. Yes, but that's not what the database is about. The database is structured, which means the data you're saving to the database, that system has to be organized, has to be structured. And what helps it to be structured is the engine itself, the database itself. So it is a structured system of organized data. And what happens is this structure helps you in storing the data very well, like as I've mentioned, helps you manage the data, and then as well also helps you in retrieval, because there's a structure around the data. The structure around the data, it helps you to do all of that. Now, there are different types of databases. You have the relational, you have the NoSQL or NoSQL, you have the in-memory, you have graph, you have spatial, you have lots of them. But this is just an intro, right? So we'll be focusing on majorly what is needed for the cloud practitioner exam. So with this in mind, let's move over to AWS and see how, this relates. Now, close this chat, okay. So when I talk about relational database, it has to do with rows and columns. Now, you can see a picture of Excel to your right there. It means it's stored in rows and columns, right? That it's obvious you can just go to a particular column and then retrieve the emails, or you can search column. But of course, you get all the record based on the field or based on the cell you're searching on. Now, that's what relational database is about. Besides that, relational database gives you the ability to link your data. So it's more like there is some kind of relationship or some kind of relation between the data that you've saved in the database. So relational database gives you that structure of table and column and rows, and then gives you the ability to do that linkage. If you go deeper into relational, that's called foreign key referencing. So you have a table or a particular sheet, as you have in Excel, referencing another sheet. So you have that data connection there. So relational database helps you do that, enables you to do that very effectively. Now, another example, like you have the document or the snapshot down there has first name John, last name Doe. It's just a snapshot of the type of data that can be saved in a NoSQL database. Now, NoSQL, okay, I call it NoSQL. So, so it simply means the same thing, right? Pronunciation, it is SQL. SQL is actually an acronym for Structured Query Language, right? So what's the NoSQL database? In the relational database, you use the language.
Sorry to break you.
Okay.
Yeah. So like it's breaking. Maybe you can turn off your video. I think it can improve. Like the internet is breaking. I don't know why.
Okay.
Yeah.
Sorry about that.
Yeah, but it's not that bad. Just yeah.
Okay. All right. So now I was trying to explain NoSQL part and the relational parts. Now, for relational databases, you use a language called structured query language. That is SQL in short. Use SQL to interact with the data, to manipulate the data, to retrieve data, to save data. So you use the language SQL to do that. Now, in NoSQL, you don't use that structured query language. You don't use that language. You simply interact with the data to save data to the database and to retrieve data, whatever you have. That's so the NoSQL, apart from the shape of data you can store, it doesn't save data in columns and rows. It saves them as JSON documents. And the snapshot you have there is an example of a JSON document. So you can hold, so if you have, for example, some kind of document that has a family tree contained in one document, you can save all that document as it is, right? You don't need to now try to split them into rows and tables as you will, or as you would do in the relational. So that's the major difference between the relational and the NoSQL. The in-memory simply means it is in memory. It is, I'll say this carefully, for beginners, we can say it is not written to files. The in-memory database, it is not written to file. Of course, there are advanced ways, or when you go extended into in-memory database, you can actually write the file. But the whole idea of in-memory database is that your database is held in memory, and it makes it really, really easy for you to access. So if you try to access data from maybe your relational or NoSQL databases, and it takes, for example, 5 milliseconds, it should be smaller. It should be a shorter time when you're trying to access it with the in-memory database. All right, the next is the graph. So an example, you can see an example there. That's what the graph, the structure of the graph database looks like. So it just connects different points to another. A very good example, in fact, one of the examples that is always used almost everywhere is that Facebook uses graph database. Right? Now that graph database enables you connect different, that's why you have a friend request from here, and you can connect from this friend, you can see the whole of the families and all of that. So graph database helps you do that. All right, now let's get into AWS proper. Now, having understood the basics of database, let's see how AWS translates this and provides services. Now, I have two services here. One is RDS and the other is Aurora. Let's take a look at RDS. RDS is Relational Database Service. From the explanation, I'm sure this should be a bit familiar. You should be a bit familiar with what this can provide. So it is managed, meaning everything about the operational part of it is handled for you by AWS. What this means is you really don't need to install any database engine on any server. You don't need to do the backup yourself. You don't need to you don't need to patch the systems or any security updates that needs to be done. AWS handles it for you. That's what it means by a managed service or a managed database service. Of course, it is SQL, so it utilizes, of course, it's relational database. Of course, so it utilizes SQL. So you can use SQL to query data and then, of course, insert data and manage the database. It supports Postgres. I'm going to explain this a lot more. It supports Progress database, MySQL database, Microsoft SQL Server, Oracle, MariaDB, and Aurora. Now, database is a call it computer science concept, right? Now, different companies have their own implementation of what database is, right? Different companies have that implementation. So Postgres is an implementation, right? A company's implementation. MySQL or MySQL is another company's implementation of the same idea of relational database. Now, Microsoft SQL Server is Microsoft's implementation, Microsoft's idea of relational databases. You have Oracle, and then you have MariaDB, and then Aurora, which we're going to talk about much later. Now, what this means is RODS is a service that allows you or gives you, that provides the ability to create databases based on any type you want, which means I can launch the RODS service, which of course, during the hands-on, we're going to see. I can launch the RODS service, and then I can decide to create a database. Now, I have the ability to now pick or select the type of engine I want, or the type of this, we can call it manufacturer, if you will. So I can decide to create a database that is by Postgres or by MySQL. Incidentally, MySQL is also owned by Oracle, and Oracle have their own database named Oracle as well. So I can decide to create a Microsoft SQL Server or MariaDB or so. What happens? What this means is RODS is like I don't want to call it an umbrella service, but sort of, right? It's that service, that gateway service that enables you to create different types of database on the cloud, on AWS. Now, moving on to Aurora, it's proprietary, meaning it's owned by AWS. Now, it is similar to the RDS databases, which means it uses SQL. It is also managed as well. Now, it only supports two types of database. You can see there. While the RDS has support for Postgres, MySQL, Microsoft SQL, Oracle, MariaDB, and Aurora also, and MariaDB, Aurora only has support for Postgres and MySQL. Now, it is also optimized for the cloud. The question is, I thought relational database was also for the cloud. Yes, it is for the cloud. But here's the thing. The relational database service, it's more like, okay, I want to be able to use Oracle inside of AWS. That's what the RDS is about. Now, for the Aurora is AWS's components. So some features that are not specified or were not implemented or are not available in the traditional database engines like Microsoft, Oracle, and the rest, they now add it sort of. So it's like, this is our own database, right? It's AWS's own database, but it also supports Postgres and MySQL. It is optimized for the cloud, as you can see. And then because of that, call it the AWS magic, it is faster than MySQL. It is 5 times faster than MySQL and 3 times faster than Postgres on RDS. So comparing RDS on relational database, on RDS and Aurora is faster. Of course, it costs more because it's more efficient. So this is like the first two. It talks about relational database. So let's get to the next one. So we have DynamoDB. This is my best service, so to speak. So it's a NoSQL database. Remember the definition of NoSQL. It doesn't follow the normal or the standard column and row structure, right? And it doesn't use database. It doesn't use SQL for manipulating its data. It is fully managed. Of course, you know that fully managed means the operational overhead is handled completely by AWS. It is highly available. Now, when we say highly available in AWS or in cloud technology, it simply means that if you should design your system or your database, in this case, in such a way that if you have more than one replicas, right? You have more than one instance. So if I have one database running, it should not be just one, it should be more than one. So that if one goes down, I still have my data. I can still manipulate my data. I still have access, so to speak, to my data. So it is highly available. And most times when we say highly available, it says it has about 3 replicas across availability zones. I just hope I'm not going too technical. Across about 3 availability zones, which means if the availability zone in maybe the first AZ goes down and it's in country A, for example, or if it's in a state, is in maybe particular, the way we categorize it in here in Nigeria. So if it's in a particular, say, local government A, and the one in local government A goes down, you still have access to the one in local government B. Now, I just use this to give an illustration. Doesn't necessarily mean that's how far apart they are. And that's, I'm not necessarily also necessarily saying that's how near they are to. So basically just for instance purposes, right? So when you have availability zones, it means you have something similar to a data center distributed at different places, so that when you deploy your database, you can deploy it to have 3 instances. Now, those 3 instances will not reside in one availability zone, in one data center, so to speak. You can distribute them so that if anything happens to data center A, of course, you can still get your data and recover and then get on with work. So that's what highly available is refers to. Now, DynamoDB also scales to massive workload, which means it is responsive, highly responsive. In fact, it has been documented to receive or respond to millions, if not billions, of requests in a very short time. Millions of requests in seconds. There are quite a number of use cases all over online. It is distributed. Like I said, the idea of distributed is what I described in being highly available. So you can distribute it across different locations. In fact, that's what the cloud is all about, right? And then it is serverless. Now, what it means is you have no need to think of servers. Now, when it is fully managed, you have a bit of configuration to do, right? That relates to, you have a bit of configuration. But when it is serverless, you just work basically on what you intend to do. Like, okay, I just want my table to be set up. So the table is what I'm concerned about, right? But when it's not serverless, you have some setup to do. For example, on RDS, of course, we are going to see this when we go to the hands-on part. In RDS, I have to create a database. I have to set the engine I want. Remember, we talked about that. I have to pick if it's MySQL or the other. In this part, all I care about in DynamoDB, all I care about is my table, right? I care about my table and how to make it available for my application. So that's what serverless is all about. So moving on, we'll be looking at Elasticache and DocumentDB. Now, we talked about an in-memory database, right? So to use an in-memory database on AWS, you get to use Elastic Cache. Now, in the software development world, it is called a cache because you can quickly retrieve data from it, right? So now, Amazon Elastic Cache provides two services or two engines from which you can decide to use. So you can pick either a Redis engine. Redis is a well-known, very scalable cache engine, right? In-memory database engine. Memcache is also another type. So just like we had MySQL, PostgreSQL, Oracle. For RDS, we have Redis and Memcache for the Elastic Cache. And remember, this is an in-memory database. So if you want maybe an exam question that has to do with if a scenario where you want to quickly retrieve data, right? Instead of going to the database and coming back, making that request, you want to quickly retrieve data, especially data that doesn't change quite often or that doesn't change at all. For example, when you register maybe on a site with your first name and your username, no, we rarely go back to change it, right? So details like that, when they are queried or when the data is frequently used, it can be saved in an in-memory store, in-memory database. And then Amazon provides the Elastic Cache from which you can pick either Redis or Memcache. I hope I'm being heard. I hope I'm not being too fast.
No, but I would encourage the attendees also to maybe ask in case they don't understand. They can maybe ask in the chat. So I will maybe stop you with the question.
Okay, sure. That'll be nice. That'll be nice. All right. So moving on to documents DB. Now, there's just like you have Microsoft SQL, and the other types of relational databases, you also have a type of NoSQL databases. So remember, NoSQL is just saying, hey, we don't want to have the structure in columns and rows, and then we don't want to use SQL, right? So one of such NoSQL type databases is MongoDB, right? So MongoDB is a company that produces NoSQL database. So now, DocumentDB is AWS implementation of NoSQL database, right? So of course, it can be used to store data like other databases, like your JSON type data. It can be used to query and index data as much as you would. It's fully managed, highly available, and then of course, replicated across 3 AZs. And then it grows in 10 gigabyte bits and can grow up to 64 terabytes. But I know I've worked with large data, but I've not gotten up to 64 terabytes worth of data, which means it is very, very large, right? It is very, very large. Now, at the end of this session, there will be a hands-on. For the exam, you're supposed to know very well. What you're supposed to know very well is the RDS, Aurora, Elasticache, DynamoDB. Then for others, as we're going on, it is just basically have an idea, know what these things do, have an idea of this service, so to speak. So the other services may not really go into demonstrations of those ones. So it will just be quick, fast, then. All right. So we have EMR. Now, EMR is a service that helps you create Hadoop clusters. Now, Hadoop is a service or some kind of engine that you can use to perform big data kind of analysis, right? Now, when it comes to AWS, your focus will be EMR, and then when you create that MRO, you can process very large amounts of data. Apache Spark is one of the well-known big data engines, so to speak. So MRO supports that. We also have what do you call it, HBase. Now, what EMR does is it provisions and configures your Hadoop cluster, right? It does that for you. So when you set it up, all you do is just go in and then starts working on it. Right? We have QuickSight. QuickSight is business intelligence machine learning powered interactive dashboard. So if I have some kind of data and I want to I want to create a dashboard. Of course, when working on lots of data, you need some kind of dashboard so you can quickly understand some kind of trend. You can understand what's happening, both in business, even in database engines and the rest. So now you can use QuickSight to create very interactive and intuitive dashboards with which you can now see, okay, this is what's going on, this is what's happening, and all of that, right? QuickSight helps you do that. It is fast, it is automatically scalable, which means you don't think of servers. Now it has a per session pricing, which means for every time you go in or log into the QuickSight session, that's when you'll be paid. That's one of the beauties of serverless. So once you're out, once it's not being used, you're not being charged, right? So of course, it is used for business analytics and then visualizations and quite a lot of things that businesses require that you can, at a glance, just get an insight, right? At a glance, get an insight of. The next service is Glue. Now, what is Glue? So Glue is a fully managed and serverless extract, transform, and load service. Now, what does that mean? Glue takes data from a particular source. Of course, you have to define that source. The particular source or sources, it can be one, it can be more than one. It takes the data, that's the extract part of it, and then transform the data into what you want. Of course, you have to determine your shape, whatever you want your transform to be. Now, it transforms it into what you exactly want, and then it loads it up for use. So Glue is that service. Of course, if you are doing this on your own, it will require you setting up several servers and maybe some kind of, you must have very good understanding of some programming languages and all of that. But with Glue, you just select your data sources and then determine how you want your data to be transformed, and then it loads it and makes it available for use for analytics and any other thing you want to use the data for. Another concept that may come up in the exam is the concept of data catalog. It's a catalog of data sets used by Athena. We're going to see what Athena is later on. Athena, Redshift, and EMR. Of course, we've talked about EMR just here, which is the Hadoop cluster. We're going to see Athena and Redshift further down the line. Interesting. So they come next. So Redshift is based on PostgreSQL, right? Now, it is used for online analytical processing, basically analytics and data warehousing. So that's what Redshift is used for. If you're conversant with OLAP services or OLAP engines, you know that it's not always you read data. So it loads data periodically. I think with every hour or so. You cannot really access every second like you would a relational or no SQL kind of database. So it loads data periodically. Now, Redshift itself is 10 times better in performance compared to other AP databases. Now, the data is stored in columns, not in rows. So this is another type of database. We talked about tables and columns and rows. Talked about that JSON object. We talked about the graph. This is another type. So data is stored in columns, not in rows. So if you need anything, you just go to a particular row and then that's all you get. So you don't use a field as you would in RODS or in Excel. You don't use a field to get all a particular row. Once you get the field or once you get the column and get the whatever you're looking for, that's all. So it's really fast. Of course, on AWS, it's a pay-as-you-go model and based on the number of instances. Now, what that means is this runs on a computer, or call it an EC2 server. Simply put, let me just simplify it that way. It runs on some kind of server or VMware of virtual machine. Now, if you have up to 3, it means you pay the pricing will be pay as you go based on 3 instances. So the instances refer to your VMs, the server engines that are available. So if you have 5, it will be pay as you go according to 5, right? And then of course, Redshift provides SQL interface for manipulating data. The next is Athena. Athena performs analytics against S3 objects. So to understand this, because you need to know what S3 is about. S3 is some kind of storage service on AWS where you can store files, you can store, call it object storage, yeah, where you can store files, store some kind of binary data, whatever you feel, audio, you can store them on S3. Now, what Athena does is that it gives you that ability to be able to query or perform analysis against those objects stored in S3, right? Wonderful thing that it uses SQL. So you can use your SQL code, your structured query language, to query objects. Take note, this is not some rows or row and table kind of structure, row and columns. This is objects, but Athena gives you that ability to query those objects as though it's the object or the data you're querying were in some table and some table structure. All right, so it supports JSON, CSV file format, supports JSON, supports ORC, and some other formats. So if you have these files, these file formats in your S3, it means you can query them using SQL because Athena gives you that ability, right? Provides that support for you, that service for you. Now, it compresses or uses column data so that it can reduce cost. Remember, because in Redshift, because data is stored column-wise, it's very fast. And of course, that's the same concept here. So it can be used for business intelligence, can be used for reporting, can be used for analytics, and many other services. So remember that we are discussing database and analytics. So it is data, how data is stored, and then the tools that you can use to manipulate data to whatever you want. That's analytics. All right, moving on to the next.
Telephone nimbu chila. Yeah, and your chumitsonga.
Right, moving on to the next. We have Neptune. Now, Neptune is a graph database, fully managed, highly available across 3 AZs. It can store billions of relations with millisecond response. So remember we talked about Facebook having or using or implementing the graph database, right, for it to function. So it says you can store billions of relations.
Kasi yambuza maze wavugana nshuti.
I don't think any of us have
Oh, eh?
billions of relations with respect to friends and all of that. So, but of course, if you have up to 1 million, that's where the graph Neptune comes in. So Neptune gives you that these provisions, these for you, and then it is fully managed, which means you don't need to install any server. Of course, you need to set up your configuration, right? It gives you that, provides this for you, and then you can go in and do whatever you want with your database. The next is Amazon QLDB. That refers to quantum ledger. That's the ledger. It's supposed to be ledger there. So quantum ledger database. So basically, you know what the ledger does? It helps you keep financial records. So basically, it is fully managed and serverless, highly available. Now, the basic use is you can use to review history of your changes, maybe to your application, whatever you're saving to it over a period of time. And the big deal about this is it is immutable, which means once you save a record, it cannot be removed. Of course, if you want to look at changes or history over a period of time, then it doesn't make sense to remove data at an earlier period. So the entries cannot be removed, and every entry is verified by cryptography. Now, it is not decentralized, right? It is not decentralized. I know the word ledger makes it still a little bit towards the blockchain kind of ledger, but this isn't decentralized. All right, so let's look at managed blockchain. So it enables building of blockchain applications, and of course you can use this to create your own stable private network. So if you want some kind of database that suits or that serves a blockchain kind of application, then you can use managed blockchain to do that. Of course, it is a managed service, and then it is very compatible, highly compatible with the well-known blockchain databases out there, which are Hyperledger Fabric and Ethereum. So now, all you need to know, you can notice these ones, I'm just like flying through them and all of that. You just need to know, okay, Neptune is available and this is what it does, right? You're not necessarily required to have a very deep knowledge on how they work or how to set them up. You just basically need to know that, okay, this is available, right? All right. Now, this is say the last thing I'll talk about before we'll talk about questions, because I don't think it makes sense to go without questions. All right, so the DMS is Database Migration Service, one of the very wonderful, amazing services on AWS. So what it helps you do is it helps you migrate data to AWS database. Now that's limiting. Now you can migrate data inside of AWS, right? Basically what it does is you pick a source. You may have a PostgreSQL database, right? And you want to migrate your data from there into AWS, maybe on to MySQL or Microsoft SQL Server. The DMS does that for you perfectly. It is resilient, self-healing. That's a very big deal. Self-healing means if it encounters any issue, it can fix that issue in quotes and then continue operation. It means there's no downtime once it starts. And of course, it is very secure. The good thing about the database migration service is that the source remains available. Some migration services, you have to run them. When you run them, the source will not be available. What that means is you cannot access that database until the migration is done, right? But using the DMS, your database is available for any other thing you're doing. For read, it's available, so to speak. So it's not down during the migration process. And then DMS supports homogeneous migration, which means same database, right? So I can migrate from MySQL to MySQL. I can migrate, and then heterogeneous, which means I can migrate from different databases, from Oracle to Microsoft Server and the rest. So this is now, there's a part I'll talk about that has to do, let me just talk about it. It has to do with the deployment options. Read replicas. Now, what happens is, for read replicas, if you have one database, or one instance of your database, you don't want a situation where, please confirm you can hear me. I see connection is unstable. Can you hear me?
Yeah, we can hear you.
All right. So you don't want a situation where that one database is loaded with, that one instance rather, is loaded with all the reads, all the writes, right? Especially if you have more writes or more reads, either one. So what you can do with your deployment pattern is that you can have one or two read replicas. What that means is you can have two other instances of database that enables you read only. You can only read from those instances, right? Now, when you read from those instances, it reduces the burden on the central database, on the main database. And now the database can now be used for writes only. So if you want to save, by writes, I mean saving data to the database. So when you save data to one instance, the data is replicated into the other database. So those other ones are called read replica. So I've come to then the end of the talking phase, and then I would like us to just take some questions, and let's see how far before we get into the other part of the hands-on. Thank you. Cynthia?
Thank you, Charles. I think now we don't have questions, but maybe during hands-on, usually people ask questions. So you can follow with the hands-on, and then I will alert you in case of any questions.
Okay, sure. All right. Okay, so let me quickly launch my instance and then share the screen again. Okay, so I'll be sharing my screen now. So please confirm you can see my screen, please.
Yes, I can see that.
Right. So this is the management console. So there's several ways to get to RDS. So now this is listed here because, of course, you can see recently visited, but yours may not be like this. So what you can do is enter DMS as service, see it here. Oh, sorry, my network is a bit slow, so I'll change that to RDS. My bad, sorry. Guess it's just because I just finished talking about migration. All right. So you go ahead and click your create database. Now you can see what we talked about. Suppose so you have to pick an engine type. This is Aurora. This is MySQL compatible, Aurora Postgres compatible. So this is the Aurora part of it. So Aurora only has compatibility for MySQL and Postgres SQL, right? Now, but we are not looking at Aurora because it's not in the free tier. So let's pick the standard, and then we'll pick MySQL, right? Now, these are, like we mentioned, these are the other supported engine types. Okay. Now you have a template. You can either set for production or for dev or for test. Or you can use the free tier, which is what we are going to be using. Okay, so I select the free tier. Let's look at this. If the production template is selected, you can see multi-AZ is enabled here. So you have deployment options. This is what I was talking about. So deployment options. So you have multi-AZ DB cluster, meaning multi-availability zones database cluster. Right? So if you select that, it's going to create a cluster with a primary DB instance and 2 readable standby. So the readable standby was the read replica I was talking about, right? And then you have other options here. Okay, you have other options here, the single DB and all of that. But of course, we are not interested in this. So let's pick the free tier. So we may leave most of this, may just leave it the way they are. You have the username admin. You can just leave this as default. You can decide to enter the master password. Password is always an issue. I hope I get this right. Okay. So we said it. Remember, the user is admin. Of course, you can change it if you want to, right? Master username. You can change if you want to, but we'll just leave it the way it is, and then set the master password. And then, of course, because this is the free tier, you're limited. See, all these are grayed out. You're limited to the kind of engine. So you just have 2 virtual CPUs and then one gig of RAM. And then you have about the 2 gig network for relating with your data. So we pick this. You can select what's the storage type you want. And then we are allocating 20 gig to this. We don't need this because, well, this is just a test. And basically for the simple setup, you don't want to go so far. All right, connectivity. So don't connect to EC2, connect to. So what this means is, do you want your connection to the database do you want to connect to the database EC2, the VM that's actually housing your database? You can click don't connect, you can click connect, whichever one. Of course, it selects a VPC for you. This is beyond the scope of today's lesson. And then do you want it to be publicly available? Of course, yes, because we'll be connecting to it using an SQL client. So I think that is basically what we want to do. All right. So you can see down here, it gives you an estimated monthly cost. So if you keep this running for a month, you can see what the cost will be. So it says the storage is this, and of course you have a total of 14 USD. Of course, this is a test. So let's go ahead and create a database. So it takes a while for you can see creating database. It takes a while. You can see the status here, or if you don't have this, it takes a while for it to be created. So while it's creating, the database, what's being created is the engine where the data is going to be stored. Now, you may want to have access. Okay, I think I see someone has raised the hand there. Go ahead, Ken.
Okay, I had a question on the configuration. It's just that I think I took a bit of time to raise my hand. I was trying to look for that feature on my phone. There's usually this part where you have to enter the database name. And sometimes it's usually hidden. And when you don't do that, maybe you're not able to connect to the database on RDS. Maybe you can shed light on why is it like that, and why is it always hidden? Like you have to like expand that section. I don't know whether you can go to the creating of the DB, that configuration area, so that I can show you that, and maybe you can shed light on what I was asking. Yeah, I don't know whether you're getting my question.
Yes, I do. I do.
Okay.
So while we're going to go through that, one thing I'm going to say is most persons, in fact, nobody creates database, a production database, by coming to the console, right, to create a database. I'm just saying this so that you just have it all at the back of your mind, sort of. So you do most of it with code, right? You do most of it with code, and then, of course, while creating your code, you must specify the database name. Okay, so
yeah, so it's usually under where? Under additional configuration or what? Just down there.
you let me know
I think it's I just scroll down.
Okay.
Yeah, there.
Okay.
Initial database name. You can see it doesn't have a name or something.
Yeah.
And usually been seeing the first time I ever did that and they did put that name, it had an issue. Yes, I understand. Maybe you can use something like CloudFormation or Terraform or maybe the AWS CLI to do this, especially for production, and it's going to solve some of the issues. But maybe I was just asking for your opinion on this. Yeah, especially using the console.
Okay, so the term database actually refers to a whole lot, especially in reference to context. So I can say database, and then I'm referring to database management system, which refers to the different types of engines like MySQL, Oracle, and the rest. Now, we have created a database, right? Now, that refers to, we have created an instance of a MySQL database. I don't have a database itself where I can store records. So this is saying what you have this option, this database option, right? It's saying, I want my creation process, right? I want this instance of MySQL that I'm creating to come with a default or an initial database where I can now create a table inside of it. Right? So if you read this down here, it says if you do not specify a database name, RDS does not create a database. What this means is you will have to create that database by yourself. For example, creating a database on relational database, you have to use the create database statement, right? So I'm going to use, because I didn't specify any name here, I am now responsible for writing the create database statement. But if I specify a name here, then the creation process is going to also come with an initial database with the name I insert here. I don't know if that's clear, or I can still
Yes,
explain.
thank you. It really now makes sense that there's the RDS, which is the instance, like for example, like an EC2 instance, and then you have now the database itself that is going to be there. And maybe since you're going to be using a client, then you're going to create now that database once the instance is up.
Absolutely, absolutely. So the little not really confusion, but it's just one word referring to a lot of things. So like I said, I can use database and I'm referring to the different types. I can use database, I'm referring to the instance. And then I can use database, I'm referring to the actual database, what you're referring to. So there are different nomenclatures, so to speak. The same nomenclature for different items. So if you enter this, then it creates. If it doesn't enter it, you are responsible for doing that. All right. Thank you so much.
Thank you.
Yeah, thank you so much for the question. So it says our database has been created successfully. All right, so we have the identifier, it's backing up. We have an instance. So this is a database instance, right? Now the engine is MySQL, right? The BAZ, remember this is free tier, and with free tier, we don't have the provision for read replica, right? And then the size of our instance is this. We can see CPU usage and all of that here, right? All right, so to log into it, we may have to share. Okay, log into it, let's click this so that we can see some other configuration. So, because this is what we saw initially, but now we have connectivity and security. So this is our endpoint. So your database endpoint is your database endpoint is the link through which you can access your database, right? So that's the server URL. If you want to put it that way, that's the server URL you can use to access that. Now
I have a question.
Okay, go ahead.
Yeah. Okay, so now that we did not specify a name while creating this, does it mean what we created is the database engine or the database?
What you created is an instance of, it's just like you have an instance of EC2. So
Okay,
an instance of
a database
exactly.
engine.
Exactly, that's what we created, right? An instance of RDS or an instance of MySQL database. That's what we just created. Exactly. Can you hear me?
Okay. Okay, without the name specified while we were creating it.
Yeah, so like I said, what you're asking about is the database schema or database structure where I can create tables inside.
Oh, they are different. Okay, okay.
Yeah. So don't worry, we'll get to that point. Hopefully that will clarify a lot of things. Like I said, it's like saying you one word for three different things. So it could be confusing, especially if you've not tried it before, if you've not really understood the concept. So let me copy this and try to, means I have to share my screen again. Just a second. Okay, let me see if I can share this other screen. Okay, let me know when you can see my screen. It is a, can you say it's a MySQL Workbench application?
Yes,
Can
you
you say?
can see. You can
Okay,
see.
nice. Okay, nice. So this is a client that you can use to connect to MySQL, right? So because there are several clients, this is one of the ones that is provided by MySQL. So I can just say AWS is the, this is just a name. And then the host name here, I want to put that connection, right? That connection link that we had. Of course, if you look at that place, the port is 3306 as well. Now, remember, we had the user as what? Admin. And then we're going to enter the password. I hope I remember the password, okay? Okay. So let's test connection. So this could be, it could be network issues. So strange that I'm having network issues today, but anyways. It could be network, it could be password. So, but of course, it's supposed to, it will let us know if it's a password problem. So what happens is when this logs in, when this goes through, we'll now be provided with an interface where we can then query or create, okay, so this is failed to connect. So I think, let me change the password and then we'll try it again. So when this goes through, we're going to be provided with an interface where we can now write structured query language, which is our SQL. Now, using SQL, we can now create, Kevin is coming again, we can now create a database. Now, that database is now the schema where we can now create tables to store data. So you say failed. I wonder why this is strange. I mean, I've forgotten the password. So while this is going, let me see if, let me go back to ideas and see what's happening there. Okay, so I'm still having issues connecting. So let me get back to RDS. Please, what screen are you seeing so that I know you're playing? Can you hear me?
Seeing
Yeah.
the MySQL workbench.
Okay, that's not good one. Okay, let me stop and share again. Okay, I think it's this one. Yeah. I think I have all inbound. Let's see if we can modify the password. TXT1. Okay, I think very good. So yes, apply immediately. So Kevin, you can see here it says modify DB instance. So I think this is the right classification for what's the one we just created, an instance.
Yeah. Yeah, it now makes sense. It now makes sense.
Okay. All right. Okay, so then I think I can share, I should be able to share multiple screens. So yes. Okay, and then test. I'm doing that. I could also use another client. So obviously this is network related, I believe, because of course I did a test before now, then it was seamless. So I believe this is.
Charles, I have a question.
Yes.
I don't know whether did we enable public access when you're creating the DB?
Yes, I did. If you click
if you look at this, maybe the security group.
so I guess it's a network issue. So because this is supposed to have populated by now. Anyways. So can you see that?
Yes. I can see it is there. It is also as public access.
Yeah, it's enabled. Yeah. And then what I was trying to do the other time was to check the inbound rule for the security group. So it says all, which means all the ports are open. But we could still try. This is, of course, beyond this lesson. Well, so let's go back here and do a test. Apparently the host name is correct, the username is correct. Okay, so we've been able to connect. Can you see that?
Yes, yes.
Yeah, so successfully made the MySQL connection. So we can now okay it. Okay, so this is, we just have, this is what's available right now in the instance we just created. What's available is just sys, and sys refers to the system table, right? Now that table holds the logins, the security, the config, of course you can see that. Now that's not business. So what we want to do, so this is what we are asking, Kevin. So here we can now do a create, table. Of course.
We are not seeing that screen yet. What we're seeing is your console.
Oh,
Yeah.
Okay, so can you see it now?
Yes.
Yes, we can see.
So we can do this. It mustn't be all uppercase. This is just whatever convention that suits you. So if we run this, it has created this for us, right? So we can say this is what you are referring to. So if we had put in any database name, or if we had put in UG_Kigali, then right here on our left, we would have also had Kigali. Do you understand? That is what the initial database, the question you're asking, that's what it's referring to. So I've switched to use Kigali. So here I can now do my create table. What do I use now? Say participants. Yeah. Need to take this off. And the create table participants, where I can then specify the ID and all those things. It's not now. And then, because this is my SQL syntax. See, first name, maybe a username just for time. Or we can just see Nick. And then if we run this, our table has been created. So if we refresh, so you can see Kigali is listed here as a database. Do you understand that? So this is the right nomenclature for this will be a database schema, right? But of course, as you communicated and told, you just want to call things very quickly. So this is also a database, but the right name is a schema. So Okay, of course, you can see it down here. So we've created a table, and the table is participants, right? So all of these we have done is resident or resides in that database instance, right? That we created on the AWS console, that's via RDS, right? So this is RDS. We use MySQL. Of course, we can use MariaDB or MySQL or Postgres or Oracle. But of course, we pick the type that we want, right? So this is one part of the hands-on. The other part of the hands-on will be to look at, what do you call it now? DynamoDB. Like I said, DynamoDB is in fact, is my best service. So I can talk about DynamoDB for the whole day. Okay, I see a question. Does it mean we don't have to give the name to the instance? No, it's optional. Like what I said was, if you specify the name when you're creating the instance, if you specify an initial database name when creating the instance, you wouldn't need to create another schema here. So that name you're specifying is for the instance to create a schema for you. I hope that's clear. It's for the instance to create a schema for you. But if you don't specify the name you want to call your schema, then it means when you come down to a client, which we're using Workbench for, when we come down to a client, then we have to create that schema, because of course we cannot make use of the database engine without a schema, right? So you have to create that schema, that's database schema. I hope that's clear, Hubert. So I think, let me take, if there are any more questions, let me just take this question before we move over to DynamoDB. Are there any more before I try to set up for DynamoDB?
I had a question regarding creating users, like how maybe you might want maybe other people to access your RDS without using the admin user or something. So what is the easiest way out, or just how to write the SQL statement to create users and give them privileges?
I think the best way is just to, like I said, most of these things will be automated by scripts in production, right? But of course, when you're doing a test and there's nothing really private, so to speak, I think you could create, because what we're using to log in is the master user. So we could create another user. Right? Where we can now give the access. We can do that using, what do you call it? SQL query language here. Right? We can do that using SQL query language. SQL, I think I'm saying the same thing twice. You can use that using create table, create user statements, I think, and then assign some kind of privilege to the database you want. It's been a while I wrote SQL, so I may not be able to provide you with that code, but of course, it's something you can get online. I think I saw a hand raised. Kevin, are you okay with that? And then I saw a hand that was raised. Please.
Sure. Thank you.
Hello, my hand is raised. I don't know if it's me you're talking about.
Okay, go ahead.
Okay, I wanted to find out, is it possible, like through the AWS console, if you already have some kind of data in, like, for instance, Excel, that you want to, is there a possibility to automate it through AWS into the database as it's spinning up, or you have to always just write a script from production that can do that for you?
I don't know of when you're creating I don't know when you're creating the instance. I don't know. I'm not sure you can do that. There's a part where you can SSH into, you can enable SSH in. What it means is going to the EC2 running your database by console via SSH. But I haven't tried that. So it's possible that if you can get in, that is the system where you have MySQL installed. So you can, via the command line, maybe download your scripts. I'm just going through maybe a logical thing, what I'll do, download your script, right? Or if you can copy your script over into the instance and then run a dump, MySQL dump, where it now, run some kind of restore command where it now picks, okay, you say you have it in Excel, so there has to be some kind of transformation. So
Okay, thank you. I just wanted to know.
Yes, it's possible using some kind of another way. Sort of, I'm not sure you have that right on the console. Yeah, I don't know if that answers the question.
Yeah, I just wanted to know if there was some kind of trick or something that could make it
Okay.
yeah, something faster. All right, thank you very much.
Yeah.
Yeah.
All right. So, please can you confirm what screen you're seeing? I want to.
We do
We are
see
seeing workbench.
Workbench. Okay. Let me. Okay, so this was where I was. Okay. Is that okay? So this was where I was trying to explain that I don't know of any trick for loading data while. No, EC2, when you're creating EC2, you have your is it your data, something data field, something like that, where you can load in some more things using your bash script. But I can't see anything like that here. So, all right. So the next thing we want to try is what do you call it? DynamoDB. So for this, let me just change. I have quite a number of tables on that's all the regions. So let's go to a clean region. Hopefully this is clean. I'm not sure. But all right, so let's go to DynamoDB. This is one of my favorite services, so it should be here. All right, so go ahead and create the table. So take note, we are not creating any instance. We are not creating any instance. We are just going ahead to create a table. Right, so this table has to do with my application, right? Most people refer to DynamoDB as table as a service offering by AWS because you don't really see anything database, so to speak. All you know is about table. Anyway, so let's go ahead, create a UG. Now, when specifying, okay, let me talk about components of the DynamoDB table. So you have your table, obviously, you have your records, and then you have attributes. So going back to what I talked about, the introductory slide, you have that JSON object. Those names, the first name, the last name, the email, the age, all of those are classified as attributes, right? And then a full, an object that's within DynamoDB's called a record. Right, so now when creating a table, you must specify a partition key. Now, the partition key isn't really your primary key. Of course, it can be used as a primary key, but it's not really your primary key. It is the partition where your data will be located. That's what that partition key is used for. Now, DynamoDB is serverless, and it is, remember we said it is distributable, right? It can be installed or split across horizontally across servers. So that partition key is used to determine, okay, where is, if I want to get a record for Charles, where is Charles saved? What partition, right, is Charles saved in? So for example, if I have 3 partitions and they are numbered 1, 2, 3, or the ID is 1, 2, 3, right? When I save a record to the database, right, I can insert a partition. So once I specify that partition, when I want to look for my record, I have to use that partition. If I use some other partitions, of course, I will not find that record. Right? So it works like a primary key, quite all right, but it is not a primary key. So we have the table name, as you can see. Then we have the partition key, which of course you can specify. It's either a string, a number, or binary. Let's just make it a number. So what do you want to call it? So most times you see PK. And it's true that PK refers to primary or can mean primary key, especially if you're coming from the relational database side. Once you see PK, I also had that confusion. So once you see PK, you want to automatically think it is primary key. Hey, once you're in DynamoDB, it is, once you see PK, it is actually partition key first before you think of it as primary key. Now, your sort key is like your key you want to use to do a where clause, right? It can be used for sorting. So it's optional. If you want to select it, okay. If you don't want to select it, of course, you can skip it. But the most important is your partition key. All right, so for the table settings, we have default and customize. Of course, customize, you specify whatever you want and all of that. But let's leave it at default. So we have class standard, revision 5 RC, read capacity units 5, write capacity units, auto scaling on. You can see this. So it scales by default for you. Now, local secondary index, global secondary index. I'll talk about this as we go on. Then all of this. So very simple stuff, right? So let's go ahead and create a table. All right, so our table is ready and good to go. All right, so if we click in here, you can see, of course, this is details, PK, you can see partition key, source key, we didn't specify one. Additional info, this is the ARN for those that want to use it outside of the console. And then you have your CloudWatch metrics here showing you everything about your table. All right, so we don't have any indexes. This is where your global index on, which I'll explain later. All right, so to see the contents of our table, as we did, we will have to click explore table items. And you can see nothing is here. So let's add an item. So you can see that here, it means, or it has given us like a template. We specify that the partition key is PK and is a number. So we must enter a PK. Now, if a PK, let me just go ahead and do it. So we have first name, last name, email, age. All right. So this is what we want to save. Remember the JSON document? So this is what we want to save. So these are the attributes. We have PK, first name, last name, email, age. I'm tempted to click here to show you, but let me leave that for now. So let's create image. Did I create the image? Yes, let me reload it. I think I did. Okay. So we have PK1, we have age, we have email, we have first name, we have last name. Now, don't get bothered about how it is displayed. The truth is, myself, in fact, a lot of folks, it's easier to read data when it's in a tabular form than to read it when it's in some other kind of form, right? So it's easy to read this data as it is this way. So you can say, okay, I have some kind of item. So the first item has a PK of 1, an age of 55, an email of this, and then you can easily see all the records or all the items in the data in your table. But it is not saved in tabular form. It's just representing this in a way that it's easy to read, so to speak, for the eyes. All right, so this is what it looks like. So let me create something else so that you can understand. Create item. So I'll say ID 5.
Sorry, PK is unique. Are they unique? PK. Like must it be unique?
Yes, your PK should be unique. It's used to compute the hash for your partition key.
Okay, thank you.
Name, Merido, profile. Students. Details. Pass 1 cause final DB lecturer. I think I'll pick Kevin as a lecturer. Okay, so this is enough. So we can still specify gender. F. So remember, we are saving this into the same table that we had, right? So let's create a table, create an item. So now you can see that looking at this, you have the details, and that detail is for this entry. Now, we don't have details value for the first entry we had, but that's not really possible in a relational system. So I'm just trying to explain that the presentation you're seeing here is just for you to be able to easily read, not necessarily being able to, that's not necessarily how the data is saved, right? It's just that, okay, you want to be able to read, this data. Now, if I click on this, you see this data. So this has, of course, an additional object inside. If we click on this, we have a simple object, right? All right. So the concepts of scan and query, this is going beyond the exam, but I think it's also good I talk about it. Now, when you don't specify a particular key, let's say you want to get out data, right? So what you perform in relational databases, what you do, I'm sure those who are familiar will know what is referred to as select star. When they say select star, it means retrieve all the data that you have in that table. There's no filtering, there's no where clause, there's no nothing. Just give me all data. And then imagine you have a very large number of records in that table or items, either way. It means you will not be able to, sorry, it means it will take a long time, and then it is going to cost you more because the pricing pattern for DynamoDB is on read as per whatever read you make. Of course, that depends on how you set it, right? On pay per request. So for every request you make to DB, you are charged for that request, right? So what you want to do is you don't want to perform some kind of large, you're charged for that request and the volume of data that request is going to pull for you. Yeah. So you don't want to pull, if you have very large record, you don't want to pull everything at once. And really, it makes no sense to pull everything at once. You want to have some kind of filter, right? You want to have some kind of filter. Now, you can filter using this. Now, okay, before I come to filter, in relational database, like I said, that operation is called a select star query. Select star from the table name. Here on DynamoDB, since you don't use, remember, we are not using SQL, it is called a scan operation. So you can see scan selected here at the top here, top left. So it's a scan operation. So what a scan operation would do is to go through all the items in your table and retrieve all of them for you. If you have 5 million records or 5 million items, it's going to retrieve all of them for you. That makes no sense. Now you can also filter. Let me talk about this filter. Now you can decide to say, okay, I want to specify, I want to filter by a particular thing or a particular attribute. Now, the only attribute that DynamoDB knows, according to how we set it, is the PK, right? Remember I said the PK is a partition key, but it can be used for querying as well, right? If I select this partition key and I'm saying, hey, I wanted to use this partition key, it is of type, remember our partition key is a number. We pick the number, and then what's the condition? Is equal to, of course, if you drop down, you see some other conditions. So we are saying, give me the record, right, from this table where the PK is equal to 1, right? If we do this and click on run, we should get, see, item return is 1. If we do a 3, of course, I don't think we'll get anything. If we do a 0, which is the second record, incidentally, we have that, right? Now, this is, I know you may be thinking this is really limiting. Yeah. So there is a concept called global secondary index. Now, what global secondary index does is it allows you to create another key or another partition key, or it enables you to create another key where you specify another attribute as the attribute for that key, right? So let's go back there. So we have global secondary index now. So very good description. Global secondary index allow you to perform queries on attributes that are not part of the table's primary key, right? So remember, the primary key can be seen as the partition key that we specified there. So now I want to create another PK, but it is not, we don't want to use that one that we used before. So what we can do, how we do that is by creating a global secondary index. So you can now specify the partition key. I think we have age. Okay, let's use first name. I think both of them have first name. I forgot to make a very important note, but well, it's not really required, but I'll talk about it. When you're using that other filter where you specify that actually a scan is being run first before a filter, before the records are now filtered. So that isn't really a good way because of course it's a scan operation. So it's like saying, I want to get all the items that have Mary as their first name. So if I use that other filter operation that we just did, it's like saying, give me everything first, and then look for the one that has Mary as the first name, then let me have that. You know, it means it's some kind of defeated process because you still run a scan. But what helps you not to run a scan is when you have a global secondary index. So what the global secondary index will do is that it will go straight to that attribute and look for the item that has the same value, what you're specifying, and then it will return it for you. So let's go ahead and create. So we have partition key. We specify the partition key as the first name. Of course, it gives us, you can decide to name this what you want. It's just naming index name. And we see the type string. Do you want to create a sort key? Not quite, because it's, I'll say it's really beyond the scope of this. But for those that want to, I think I did a blog post that has to do with what do you call it, specifying using your primary key or your partition key and your sort key in your query. I think if you see my website, my blog or article has that. All right, so we'll just leave this for now. Let's just go with what we have. I'm not going into all this because it's not really needed for the exam. All you need to know is that a global secondary key exists and it can be used to perform XYZ, right? So let's go ahead and create the index. So most times, or if you read some articles, you see some folks refer to as global secondary index as trying to explain it to make it really understandable. Since there's a limit, if it looks like global secondary index, or you can say it can be imagined as a copy of your table, it is not a copy. You can imagine it as a copy of your table through which you can now query using a different attribute other than the default partition key or primary key. So it's creating GSI. Just hold up so that it becomes available. Since I hope I've not overshot the time, after this I should round off. Yeah, Charles, it's okay. Yes, we still have time. Okay. So like I said, remember this is for practice purposes, yeah? But when dealing with production-based workload, you won't come here. In fact, one of the tools, I have two major tools that I use for this. Let me see if I can. There's a tool by AWS, it's called NoSQL Workload. So you can use that to connect to your DynamoDB table. So let's see, NoSQL Workbench, sorry, NoSQL So just as we saw MySQL Workbench, right, for RODS, this is a workbench also for DynamoDB. So, of course, you download based on your OS and then go ahead to use it. So let's see. This takes a while to create, no? So basically what happens is when or after this is created, we can now select this query, right? If you see the tab here, originally, remember we said scan was selected. Now, if we click on this query, it means we can see this label here. It says select a table or an index. So if we pick the table, obviously we are going to be selecting from the PK, that's partition key, right? But if we pick an index, it's not available right now because it's still being created. If we pick an index, then we will have the option to specify the value as a string that will query the first name. So let's see if this guy is still indexes. Still creating. So I may have specified something that takes so long because I never create this from the console. But it's all good. So I think for me, I'll say I've come to, this is like the end of the lesson, the presentation, whatever you want to call it. So any questions that were held up or kept back, I think you can start bringing them now while we wait for this index to finish creating. So over to you guys. Cynthia, anyone?
Okay, yeah, thanks, Charles. So everyone, let's take some time to thank Charles for this insightful session. Okay, I believe, so while we are still waiting for this one to load, while this one is still loading, anyone, you can go ahead and ask any question that you have. But I believe this was insightful enough and it was very clear. For me, what I would say I've got from this session was mainly how to enable your client to connect to your RDS instance, especially in regards to the issues we faced before, where we had to allow this one into our security group things. So I would say that was one eye opener. The other thing was in regards to DynamoDB, also got to have more clarity on that one as well. And yeah, it was a very insightful session. Thank you, Charles.
Thank you.
So do we have anyone with a question? Feel free.
Yes. Yes, please. Do we have Postgres SQL Workbench the same way we have MySQL Workbench, or the MySQL Workbench works for Postgres also?
I think you have a Postgres admin. What's it called now? PG admin, yes. So let me see. PG admin download. Yeah, there you go. So if you just go to PG admin, this is your, what do you call it? Your client for Postgres database. Hope that's fine.
Yeah. Yeah.
All right.
Thank-
Okay, thank you, Hilary, for the question. So Charles, I think maybe we can go to the next part of the session while we are waiting for this one.
Okay.
Uh,
Okay, so-
also,
Okay,
yeah,
go ahead. I was going to say this is already done, so I think I would just like to finish off so that you can continue it.
okay, then, okay, then go ahead. Okay.
Right. So if we go back to exploitables, now we still have a query selected. So if I select this, let's go back here. Explore. So incidentally, I'm not seeing the index here. So let's get back. Let's see. This is okay. Let me try creating another one. Let me see if I omitted the thing. Yeah, read from base table. That was selected. Copy. Yeah. Sorry, guys. I've never created a global secondary using the console. So, but basically speaking, what happens is when you create an index, it should give me what I want. When you create an index, you have that index listed here. And then you can specify.
How about you reload this
Oh,
page? Maybe
yes.
it's still refreshing.
Let me see. And I've done that. Except some magic is about to happen now. Okay, there you go. Thanks. So we have the index here. The index we just created. So with this, with the table selected, I have PK, right? The partition key. But with my index selected, I have first name. So now I will be querying or I'll be retrieving data based only on that first name. So I can say Mary, and then if I say Ron, oh, we don't have a first name with Mary. That's strange. Okay, let's do a scan and then. Oh, interesting. Okay. So it has to do with how these things are manipulated. Anyways, so if I'm doing a first name and I do a run, what this means is it is only the second record that has a first name. We can verify that. Let's see. Let's use the table. Run. Okay, exactly. You can see that. So the first entry or the second entry rather doesn't have. I mean, let's change this guy. Yeah. So one of the things about this is it costs a lot to. Okay. let me not go ahead with that. That's going too far. Anyways, the point is this record doesn't contain the first name. So what we can do, let's add the first name so that you can see the query. Edit. Oh, interesting. So we had name, not first name. So let's separate that into first name and last name, right? Okay, so we use our index. Sorry, good. We do this and then we say we want Mary to be specified. We want Mary as the value, sorry. So if I do it, so you see, we don't even care about this filter, right? So this was the filter I was explaining that when you use it, you actually get the data for this portion of the query. So if you're using the query, all the data is gotten out first before this filter part is applied. If you're doing a scan, all the data, all the records that scan retrieves is gotten out first, it's being retrieved first before the filter is applied. But using a global secondary index, you avoid all of that. So let's run this query. And then right now we have one item that has Mary as the index. If we say, let's try for John, of course, it does the same thing. If we say, let's try for Charles, it doesn't do anything, doesn't have any record. So I think this has brought me to the end of the demo session and everything, so to speak. I hope it was really informative. I'm available to take on more questions if there are any. So I will hand over officially to Cynthia and the other coordinator. Thank you very much for having me.
Okay, thanks you, Charles. Thanks for the thanks for the practical sessions. Just wanted to highlight this one. So databases are actually some of the most asked topic in the exam, in the CCP exam. So I hope you go to talk as much as you can. And yeah, I believe Charles is still here, and remember to, so please remember to link up with him on LinkedIn. And yeah, so let's go to the next session. Charles, thank you. Maybe I can take over the presentation.
I think Kevin is raising his hand.
Oh, okay, sorry. Oh, okay.
Yes, sorry, I raised a bit earlier. I wanted to know something from Charles about the cost. I saw something about read and write capacity consumption. Maybe you can talk something about the cost, yeah.
Okay, so the read and write capacity consumption is referring to the amount of data that constitutes a unit. I don't have that right in my head, but it's something that's very readily available. About 4 kilobytes, I think so, constitutes 1 unit. And that 1 unit is charged a particular amount, something like that. So for every amount of data, so if I query data from DynamoDB, and that's the data, the size of the data of that object, right, is up to maybe 4 KB, that's 4 kilobytes, or the stipulated kilobytes, then it is charged in capacity units, right? So that's what they read, and then of course, they write. That's what it's all about. So most times when planning your DynamoDB table and all of that, you actually take all of this into consideration so that you can know the exact amount. Let's say maybe a particular page requires students' registration details, maybe all their exams and all whatnot. You want to be able to know how to handle that using the read capacity. Now, it's not, you can increase it, you can decrease. I think the lowest limit is 5. I think I remember that. But of course, you can increase it to match the size of data you want to be able to pull from DynamoDB. So for now, that's what I can say about the read and write capacity unit. I don't know if that's okay.
Yes, thank you. Thank you. Thank you so much, Charles.
Okay, thank you. Thank you, Kevin. So when you were saying about the cost, I actually remembered the thing I saw when Charles was presenting about the monthly estimate of how much things cost. So please, guys, remember to turn this off to terminate the instances when you're done. I believe that will be something good to do. But anyway, thank you, Charles, and thanks, Kevin, for the question. So the next part, we are going to do the Kahoot and try to cement what we just saw here. So, okay, let me project my screen. You can tell me when you're able to see this.
We can see it.
Okay. Yeah, so remember, guys, the Kahoot takes into consideration the what we saw last week as well. So it's not about what we saw today. What we saw today will be the main component, but it also takes into consideration what we learned last week. So keep that one in mind as well. But the justice, just to make you remember just a bit what we saw last week. Okay, so I just copied the Kahoot link. I hope you guys are able to join. Okay, I can see Serge, I can see Eric. Okay, Philbert. Okay, Ashif. Okay. Okay, Hilary as well, okay. Okay, Hilary, Martin. Okay, let's take some few minutes to have others join as well. Let's set 2 or 1 minute. Okay, let's start. Yeah, so this is the 7th practical session. So guys, good luck. Okay, so the first question goes like, you want to create a decentralized blockchain on AWS. Which AWS service would you use? 1, DocumentDB. 2, managed blockchain. 3, QLDB. And 4, quick site. So which one is it? Okay, I see. I see the majority got it right. And yeah, it's managed blockchain, as we saw last week. This the service, the database that's service which you can use to the decentralized blockchain service on AWS is managed blockchain. So let's go to the next question. I can see Arshil is at the top with Hillary and Sales following. Second question, an organization needs to regularly transfer petabytes of data to the cloud and have access to the local computing capacity. One, can we use Snowball Edge storage optimized? Two, can we use Snowcon? Three, can we use Snowball Edge? Four, can we use Snowball Mobile? Okay. As well, so we know that when we want to transfer petabytes of data and have access on the local compute capacity, we use Snowball Edge. So we can't use Snowmobile. Well, we can't use Snowmobile solely. This is Snowmobile because it's big. Also Snowcon, it's small for this amount of data. And the other one, so the possible solutions would be between Snowball Edge, compute optimized, and Snowball Edge, storage optimized. But here they are saying that they want to transfer petabytes of data, so, and have access on the local compute capacity. But the main thing is the transfer of data. So yeah, storage optimized would be the best choice here. So let's go to the next question. Yeah, I can see Kevin moving up. I should still have the read. So third question, which AWS database is a data warehouse? First one, Redshift. Second one, Elasticsearch. Third one, DynamoDB. Then last, RDS. So which one is it? Yeah, I can see the majority got this one right. Yeah, and it's Amazon Redshift. So DynamoDB and RDS are for the DB, and the Elasticsearch is just a meme cache engine for a meme cache engine service for AWS. So here the best answer is Amazon Redshift. Let's go to the next one. I can see Kevin moving up and Hillary has the lead. Hope Arshil will get to come back. So let's go to the fourth question. A team deployed in a location with low internet connection would like to move 5 TB of data to the cloud. Which service can they use? 1, storage gateway. 2, Snowcon. 3, Snowball Edge. 4, Ops Hub. So which service can they use in this case? And yeah, I can see the majority also got this one right. So storage gateway is a service. Ops Hub is also a service. Since here they are saying that they are in the low internet connection region, so we can't mainly rely on storage gateway and Ops Hub because they are services hosted on the internet. Snowball Edge is too big for this amount of data, so the best option is Snowcon. Let's go to the next one. I can see Kevin has the lead now, but I can see Arshil gradually coming up. So let's go to the fifth question. which of the following is an exabyte scale data moving service in or out of AWS? So first option, is it Snowcon? Second option, is it Snow Mobile? Third option, is it Snowball Edge? Okay, I can see the majority got this one right as well. I can see that you guys actually go to revise what we saw last time. And yeah, the answer is Snowball Solis. No. Actually, the majority didn't get this one right. So the answer is Snowmobile. So here the keyword is exabyte of data. So for Snowcon, we saw that it's only for a small amount of data. Snowball Edge also is quite big compared to Snowcon, but it can't handle exabytes of data. So when you want to move a huge amount of data from your location to AWS, here we are talking into millions of gigabytes or millions of terabytes, because exabyte is really big. So better to go with Snowball Mobile, solely Snowmo Mobile. And yeah, next question. I can see Hillary coming up. Which AWS service is always serverless and has SQL capabilities? Is it RDS? Is it DynamoDB? Is it Athena or Amazon Aurora? So which one is it? Okay, so here they are saying that the right answer is Amazon Athena. But in my opinion, I also thought Amazon Aurora can be classified as one. But here, since we had to choose one, maybe let's go with Athena, but Aurora also, I believe, can handle this. But anyway, let's proceed. So Achille has the lead. Seventh question, you would like to use a serverless service to prepare data so it can be loaded for analytics. Which service to use? Is it Athena? Is it AWS Glue? Is it Amazon RDS or Elasticsearch? Remember the keyword analytics. And yeah, I see that the majority got this one right. And yeah, it's AWS Glue. I believe Charles got to talk about. I believe Charles got to talk about this one. And yeah, I can see Kevin coming back up, and Achille has the lead. So let's go to question number 8. Which relational database is a proprietary technology from AWS and is cloud optimized? Is it DynamoDB? Is it Amazon Athena? Is it Oracle? Or it's AWS or? So which one is it? And yeah, I can see the majority got this one right. So it's Amazon Aurora. Let's go to the next question. I can see Achille still have the lead, and Eric is coming for the position of Achille. So question number 8. You want to migrate database to AWS while still being able to use the database during the migration. Which service can you use? Is it database migration service, DMS? Is it Snowball? Is it AWS storage gateway? or is it Elastic Map Reduce or AML? And yeah, I can see the majority got this one right. I believe also Charles got to talk about this during the presentation. And yeah, the right answer is database migration service. Next question. How can you create Hadoop clusters to analyze and process a vast amount of data? Maybe let me rephrase this question. How can you create a DB cluster to analyze and process a vast amount of data? So can you use EMR? Can you use EC2 instances? Can you use Athena? Or you can use Redshift? I can see the majority didn't get this one right. So here the keyword is you want to analyze and process a vast majority of data. Maybe I don't know if Charles still here. Okay. So I also think I need to look into this one more, but the answer is AML. So Access still has the lead. Which in-memory AWS database can you use to reduce the load of databases and has high performance and low latency? So is it Amazon Redshift? Is it Amazon RDS? Is it Elasticache or DynamoDB? So here the keyword is in-memory AWS database. And yeah, the majority got this one right. And the answer is Elasticache. So Amazon Redshift is a data warehouse. DynamoDB is also a NoSQL database. So here we are looking for an in-memory database. RDS is a SQL-related database. So here also doesn't fit into what we are looking here. So yeah, Elasticache is the best option. Next question. I can see Afshil still has the lead and Kevin on the second place and Eric. So question number 12, what is the name of a central repository to store structural and operational metadata for data assets in AWS Group? One, is it Group Data Table? Is it Group Data Dictionary? Number 3, is it Group Data Catalog? Yeah, I can see nearly half got it right. And yeah, the answer is Group Data Catalog. I believe also Charles got to talk about this one. And yeah, Kevin has the lead. Question number 13, which database is managed service with SQL capabilities suited for online transaction processing or OLTP? So here the keyword is a managed service with SQL capabilities suited for online transaction processing. Okay, I can see a lot of people actually went for DynamoDB. I don't know why, because DynamoDB, as I said, is a non-SQL database. Same also goes for Redshift. Redshift is a data warehouse. MySQL on EC2 is not a service. So yeah, the best answer here was Amazon RDS. I can see Kevin has the lead and Eric on the second place. Question number 14, which AWS service is an immutable ledger database? 1, is it QLDB? 2, is it managed blockchain? 3, is it EML? Or 4, is it inspector? So which AWS services is an immutable ledger database? QLDB. Now, this one, I can say I was familiar with this service as well. So I would, if I were to answer this one as well, I think I would have went with the majority. But yeah, so the AWS service which is best suited for, which is an immutable ledger database, is QLDB. So let's go to the next question. Can see our shield coming up on top. You want to set up a NoSQL database that can scale with no downtime and handle millions of requests per second. So which is it? So is it DynamoDB? Is it Redshift? Is it RDS or Amazon Athena? Yeah, I can see the majority got this one right. I believe the keyword was NoSQL database and also be able to handle millions of requests per second. So yeah, DynamoDB is the best option here. Next question. Which AWS service can create complex graphs for fraud detection? Is it Amazon Redshift? Is it QLDB? Is it Neptune or Amazon or AWS Group? Yeah, I can see the majority got this one right, and it's Neptune. So we go to the next question. I can see Kevin is on top. Question number 17, which AWS serverless service can use machine learning powered business intelligence to create interactive dashboards? Is it QuickSight? Is it Athena? Is it Aurora or managed blockchain? So which AWS service can use machine learning powered intelligence to create interactive dashboards? And yeah, can see the majority got this one right. It's AWS QuickSight. Kevin on top. So question number 18, a company would like to set up a fully managed MongoDB database. Which AWS database is best suited for this task? Is it DynamoDB? Is it Amazon RDS? Is it Elastic Cache? Is it Neptune? Yeah, can see the majority got this one. So it's document DB. Next question. Which exclusive DynamoDB feature is an in-memory cache that can improve your performance up to 10 times? Is it Elastic Cache? Is it DynamoDB Accelerator? Is it Edge Locations or Snowball Edge? Yeah. Okay, I can see half of, so I can see half actually got this right, but I can see some others who didn't get it right. So here the keyword was just DynamoDB, and the capability for in-memory caching. So Elastic Cache is not part of DynamoDB, because this one, they are saying that it's a DynamoDB feature, so Elastic Cache can be the right answer. Edge locations, just an edge location. Snowball edge is just for transferring of data. So DynamoDB is the best answer here, and it can actually improve your performance, your DynamoDB table performance by up to 10 times. So last question. I can see Kevin is on top. Phil, Hilary, Eric, and Serge. So last question. RDS Mat AZ deployments main purpose is high availability, while RDS read replicas main purpose is scalability. So is this one true or false? Yeah, this one is definitely true. I can see the majority actually got this one right. So the main purpose of RDS Mat-AZ is for high availability, and the main purpose for the read replicas is for scalability, since you can basically use these ones instead of relying on the main engine. So yeah, guys, that's it for today. I can see Hilary is the one taking the, oh, Hilary is on the third position, sorry. So yeah, Kevin, so Kevin, congratulations. Also guys, thank you for taking part into this. I saw that the majority actually were in range. You guys got a lot of could see that you were in the same range of marks, so it's a good thing. And yeah, so
Eric, we can't hear you. You're muted.
sorry guys, I just dropped off, but yeah, so I was saying I want to Okay. Okay, so I want to thank each one who attended today. It was a very insightful session, and I hope to see you next week. And yeah, that's it for me. Thank you, guys. See you.